I'm going to be solving the 2001 AMC 10 problem 23. Let's read the problem. A box contains exactly 5 chips, 3 red and 2 white. Chips are randomly drawn, removed one at a time without replacement until all the red chips are drawn or all the white chips are drawn. What is the probability that the last chip drawn is white? So we can split this into multiple cases, and those cases would be the different scenarios in which the last chip drawn is white. So we have 3 red chips and 2 white chips. So we can write R, R, R for the red chips, and then W, W for the white chips. So we know that if the last chip drawn is white, then not all, but both white chips were drawn. And so the possible scenarios in which this happens is, if it was in 2 draws, it would have been WW. If it was in 3 draws, it could have been RWW. And note that this means red drawn, and white drawn. Or we could have had a white drawn, and then a red drawn, and a white drawn. If it was 4, it could be R. Let me write this below. It could be RR, WW, RW, RW, W, RW. And note that the white has to be at the end because it was the last chip drawn. And we see that if we draw 5 chips, it could also be the last one drawn. And so if that happens, we get... Or actually, that can't happen, because what happens is that we get RWW, or we get something like this. And though the last chip drawn here is white, we had already drawn all 3 reds, and so that doesn't work, because if we draw all 3 reds, then we're done. And so this case does not work. So let's compute the probability of these cases working. So let's work case by case. So with 2 draws, the probability of getting 2 whites without replacement is 2 over 5, which is the probability of drawing a white on the first one, times 1 over 4, since we have 1 white marble left, and then we have 4 total marbles remaining. So this gives us 1 over 10 after we simplify. Now, both of these cases right here, when we do 3 draws, have the same probability, so we can just find the probability of one of them and multiply by 2. The probability of drawing a red on our first draw is 3 over 5, and a white on our second is 2 over 4, and then 1 over 3 on our third draw to draw a white. Simplifying this, we get 1 over 10 again, but we have to multiply this by 2, and so with that we get 1/5. Now the probability with 4 marbles drawn, it would be the same for all of them because it's just a different arrangement of 2 reds and 2 whites. And so we find the probability of one of them and multiply by 3. Doing so, we get 3 times the probability of drawing a red on the first one, which is 3/5. A red on the second one is 2 over 4. A white on the next one is 2/3. And then finally 1/2 for the last one. Now for this, the probability we get is going to be equal to, after we cancel out, we get 3 over 10 as the total probability. And so adding these probabilities, we get 1 over 10 plus 1 over 5 plus 3 over 10, which is 1 over 10 plus 2 over 10 plus 3 over 10, all over 10, which is equal to 6 over 10, which equals 3/5. And so that's our answer, which is D.